Welcome to Crosstalk Solutions. My name's Chris, and every so often I get emails from people who are looking for design work for special projects, and they're just looking to me for advice. And today is one of those times where I'm going to take one of those emails and we're going to actually do the design for a festival grounds Wi-Fi setup. So I received this email from a gentleman by the name of Bob Burkett. He is the chief of the Summerhill Volunteer Fire Department out in Summerhill, Pennsylvania. And Bob writes, Chris, I serve as the chief of a small volunteer fire department in rural South Central Pennsylvania. I am also the de facto computer tech for the department. I have a background in computers and networking, but have been retired from the business for several years. I subscribe to and follow your YouTube channel faithfully. Already points in his favor. Thank you, Bob. Based on your testing and recommendations, I've successfully done several small installs using Ubiquiti AC Lite APs, Edge Router X's, and NanoStation Locos. Your info has been invaluable. My volunteer department hosts an annual arts and crafts festival each fall as our major fundraiser. The festival earns us over half of our yearly operating budget. In keeping up with the times, I need to implement an outside-inside Wi-Fi network to be used each year for the two-day festival to allow our vendors to have access for their credit card processing devices. I want to set up wireless links from building A to access points on the other buildings. See attached PDF. We'll look at that in just 1 second. Equipment choices are so vast and quickly changing, I'm hoping you can help me out with the best Ubiquiti equipment selection for our application in this project. We will have temporary internet access provided for the festival by the local cable provider. As a volunteer department responsible for our own funding, cost is a concern, but we need relatively good performance and durability. Okay, so let's take a look at the PDF. Now, this is basically someone who is doing this as a volunteer setup for their volunteer fire department. And it sounds like this is a big amount of their annual budget. So we definitely want to try to keep costs as low as possible, but we have a pretty interesting setup here. So let's pull up the PDF. And here is what we're looking at. We have an area that's about 550 feet by 200 feet. This is the New Germany Grove Festival Grounds in Pennsylvania. So building A here is where they have internet. Then we've got building B where we need internet. We've got building C over here where they need internet. And then they've got two open areas. We've got area 1 right here, which has a lot of tree cover, and especially in the summertime or the fall when they're doing this festival, these trees are going to be filled with leaves. Then we've got area 2 over here, which looks like sort of a parking lot or something like that. Likely they'll just have vendor booths and things of that nature outdoors. And so red dots indicate the availability of AC power. All right, so that's really great. We've got a lot of spots where you could potentially plug in equipment. And then it says indicated buildings and areas need Wi-Fi coverage for craft vendor use. Okay, so before we dig into my design for this network, and what I'm going to do here is I will give the sort of what the design would be if you were buying everything brand new. And then interspersed with that, I'm going to give alternatives for equipment that you can buy used that would be just as good and certainly a heck of a lot cheaper. Pulling this up on AirLink, we can see just really quickly that obviously this is close enough. It's a small enough area that a point-to-multipoint network for dispersing that Wi-Fi is going to work reasonably well. However, with the tree cover over here, I'm not necessarily confident in 5 gigahertz. So I would start by going with 2.4 gigahertz for the point-to-multipoint network. And it's going to be pretty similar to the equipment that I use for my 2.4 gigahertz point-to-multipoint through trees video. Okay, so go watch that video. I'll put a link to it down below in the description. And this is all of the equipment. You can see I have it out on kit.com. Also, one more thing to mention. This is a really good cause, right? So this is a small volunteer fire department. I mean, these people are doing great work. Any volunteer fire department, if you're volunteering your time to go fight fires, you're doing an excellent job and you're doing good stuff. So if anyone out there in YouTube land has any of this equipment that they're willing to donate to a good cause, get in touch with me at info@crosstalksolutions.com. I will in turn get you in touch with Bob in case you're looking to donate any equipment to this cause. So let's take a look at the setup here. And again, I'm going to go through this sort of step by step so that we can see all of the bits of equipment as well as the various options that I've chosen for this project. You're not going to have to buy everything that I have on this list, but I did want to provide options so that, you know, I don't know the exact situation out there and I don't know the exact budget. So take all the information that I'm giving you and then rework it for this setup. But we're going to start with the core of the network at building A here. And the core of the network, I'm starting with a Ubiquiti US8 150 watt switch. So the first question, why the US8 150 watt? And it's for a very good reason. It's because it can do both 24 volt passive and 802.3 AF PoE. Okay, so you have options there for which equipment you can actually plug into it. It will basically power up any type of Ubiquiti equipment. So the mesh access points, the LR indoor access points can be either 24 volt or they could be 802.3 AF. The smaller mesh Wi-Fi antennas, those are 24 volt passive. The rockets that I'm mentioning, those are 24 volt passive. So they have a cheaper 8-port switch, which is the US8 60 watt, which has 4 PoE ports, but that switch doesn't do 24 volt passive. Okay, so if you want a switch that can do both types of PoE for no matter what kind of equipment you're putting in here, go for the US8 150 watt. So that's sort of the core of the network inside this building. Now, let's talk about point-to-multipoint, okay? Here's the thing. There are a couple of options here. I have 3 legs of this point-to-multipoint. I have one leg going from building A over here to building B. Then I have another leg going from building A over here to building C. Now, while there is a lot of tree cover, it shouldn't be a problem at this short a distance to pick up that, you know, over to building C leg. If you watch that 2.4 gigahertz through trees, I shot a distance, actually probably about this distance, maybe even a little bit further, through a dense forest, and I was able to pick up the signal, and I don't remember what I got, 100 megabits or 85 megabits or something. Certainly plenty of bandwidth for vendors that just need to process credit cards. Then the next question is, if I'm going with a rocket prism here, as well as an omnidirectional antenna, why am I doing that versus just having 2 point-to-points, which would probably be cheaper? So you could do a point-to-point, like a nanostation point-to-point, one over here to building B, and then one over here to building C. But while that would be cheaper, it doesn't give you the option to expand if you wanted to, right? So, like, let's say this optionally out here, I have an optional setup that you could take this same little setup of a nanostation and a UAP AC mesh, and you could replicate this same little setup right here wherever you need it on either side. Okay, so for instance, if you just had a dead spot over here, you could simply toss up another nanostation with a AC mesh, which can be powered by the second Ethernet port on the nanostation, just out wherever it needs to be, right? You can even put it on a stand and just have it, you know, temporarily in a location with even like a battery backup or something like that, right? So that's why I went with the point-to-multipoint as opposed to 2 point-to-point nanostation bridges. And we have some options here with the point-to-multipoint antenna as well. So what I have on the screen here is the Rocket 2AC prism. So it's a 2.4 gigahertz prism, which is absolutely overkill for this deployment. You don't need something that crazy good or that crazy expensive. And pricing wise, that is $205 brand new plus $156 for the antenna, right? So you're looking at $361 for that core point-to-multipoint access point. Now, if you buy the stuff used, I was able to find it used on eBay. The Rocket 2AC Prism was about $100 on eBay. I did not find cheaper 10 dBi omnidirectional antennas though. That was still, so about $256 if you buy it used. The option here is to go with the Rocket M2 instead of the Rocket 2AC Prism. And that'll save you about $25. You really can't get the Rocket M2 new anymore. but on eBay, they've got them for about 75 bucks used. But honestly, you're going to get about twice the bandwidth with the Rocket 2AC Prism. So I would spend the extra 25 bucks, buy a used Rocket 2AC Prism, and then the 10 dBi omnidirectional antenna. Optionally, we also have, so let's see, here's the switch. Here's the Rocket 2AC Prism. This is the omnidirectional antenna you want. It's the AMO-2G10. There it is on Amazon. There it is on eBay. And then this guy right here, this is the RF Armor UOS2X. Now this is an extra 100 bucks, but this RF Armor $100 case is going to protect that access point. Again, totally optional, because you're only going to have this thing up on the roof of that building for a short amount of time. But if you were going to have it outside permanently, I would say that the RF Armor case is not optional. Definitely get it. But if it's only for a small amount of time, if you're going to have it up for a week or two in the fall when the weather's probably not that bad in south central Pennsylvania, then you can probably skip the RF Armor device. In fact, in my calculation here, I'm just going to pull that off of the used price. We'll call it the used/optional price. All right, so let's also take a look at this link on link.ui.com. So we have this spec'd out. Again, I'm seeing like full bandwidth here. Let me move my little picture out of the way real quick. There we go. So I'm seeing full bandwidth here, no problem on the bandwidth. I'm assuming that you can get it up to about 40 feet on building A, and then we're putting it down to, well, it said it was about 20 feet less elevation over here. So we'll put it down to about 20 feet on this building over here, building B. So again, full strength, you got 100% signal. You can expect about 150 megabits per second. Actually, a little bit less than that, because on link.ui.com, the only option for the receiving antenna is the Rocket M2. And 150 megabits is the maximum speed of the Rocket M2. So having a nano station there instead is probably going to get you about 80 to 90 megabits per second. But I just don't have the capability of showing that on link.ui.com. Same thing over here, building C. We'll put it down to about 20 feet. And we have 100% signal. Again, the trees might degrade that signal a little bit, but it won't be too bad. Let's look at one other thing. Let's look at our coverage map. So if we look at our coverage, boom, look at that. This antenna is so strong on top of here. Let's zoom out and see where you can actually put the receiving antennas. You can put them all the way out here to Cleats Taxidermy, right? You can still have a receiving antenna and still probably pick up your signal. So you've got definitely room to expand, and you've got room to put antennas basically wherever you want on this new Germany Grove Hall Fairgrounds property. There should be no problem anywhere around here. Okay, so going back to the design, let me zoom out a little bit here. Here's another option. Okay, so we've got our external point-to-multipoint antenna. Then we got to talk about indoor Wi-Fi. And what I would recommend for indoor Wi-Fi is either the UAP-AC-LR, right? So the long-range antenna, because it can be powered by 24-volt passive. Or if you want to spend a couple extra bucks, get the UAP-AC Pro. Now the question is, for a building of this size, do you want one of those or two of those, right? So I put two on this drawing, but honestly, I would just start with one UAP-AC-LR right in the center ceiling of this building inside, and that will probably provide coverage to the whole building. And then you can add a second access point if you come to find out that, hey, it's just not providing the coverage that we need inside that building. But honestly, I would be shocked if one access point didn't provide the coverage that you need inside the building. Additionally, also connected to the US 8 150 watt switch is a UAP AC-M Pro. This is the UAP Mesh Pro, and I have it on the outside wall of the building covering this area over here, or at least part of the outside area where all of the trees are, where your vendors are going to be. Okay, so that's a great antenna. Optionally, you can try the UAP-AC-M, so the non-Pro version, but this Pro antenna is so darn good, I would definitely try to spend a few extra bucks to get the Pro to cover such a large area. Now notice I've got another one over here. We'll talk about that in a second. Okay, moving on though, because we got to come over here, right? So let's do our point-to-point link to our nano station that's picking up the 2.4 gigahertz link over here. Let me move my picture again. Point-to-point link over to this nano station. Again, you can expect probably about 80 to 90 megabits per second over to this device. I would put one UAP-AC LR inside. Since the UAP-AC LR can run on 24 volt passive PoE, it can be run out of the secondary Ethernet input of the NanoStation M2. Okay, so just turn on 24 volt passive PoE pass-through and you can power up this antenna. You can also power up the UAP-AC Mesh Pro that I have on the outside of this building. Again, it should just be somewhere along this wall here so that it can power up or provide Wi-Fi coverage to this outdoor area. So if they're going to have vendors out here, you probably just want it like on the corner of the building so that it can get this area back over here and then also cover this whole area right here. One of these Mesh Pro access points would be great. Again, you could drop that down to just the standard UAP mesh. That's a great form factor. Wire it in. But yeah, it's not going to provide as good coverage as this Mesh Pro. Here's the thing, you're going to have a PoE injector though for the Mesh Pro, right? Because I'm not using a switch in this building. We're just doing a point-to-point or point-to-multipoint, picking it up with the NanoStation. We're using ETH2 of the NanoStation to go over here and power up the UAP-AC-LR, and then we're using ETH1 to power up or to provide network to the Mesh Pro access point, but it will have to still have power. So you'll need a PoE injector for that Mesh Pro AP. Moving over to building C, we've basically got the same setup. We have a NanoStation. The 24 volt passive of the NanoStation is going to power up a UAP-AC LR. That's going to be the inside wireless access point for building C. And then you can optionally have another Mesh Pro out here on the outside wall of building C. So now see what we're doing here? We're potentially having one here, which would provide coverage to, you know, say this half of the outdoor area. And then you have another Mesh Pro here that provides coverage to this portion of the outdoor area. There's probably going to be some overlap. And I would say that this Mesh Pro is going to be optional based on how well this one performs, right? So if this one provides coverage to the full area, then you don't need a secondary Mesh Pro access point over here on building C. You can just get away with the one that you have on building A. But without actually being there on site and setting this up and testing it with like a wireless analyzer, I have no idea if the tree coverage is going to affect everything or affect anything, and I don't know, you know, if this will stretch all the way over to here. I could dig in further and try to figure that out, but we're not actually going to do that for this video. Okay, so the last thing that I have here is completely optional, and this is what I was talking about. You could have these little sort of pods, if you will, of a NanoStation M2 that powers up with 24 volt passive through the secondary Ethernet port, a UAP AC-M, just the smaller mesh access point, because it can be powered by 24 volt passive. So this little set of equipment here, you could literally put it on a stand, like the Wi-Fi stand that I use, and just move it around wherever you need it with like a battery. Like if you had one of those battery, what's it called? This thing, the Jackery portable laptop charger, right? The Jackery power bar could power this equipment for easily probably 4 hours or so. And so if you needed extra coverage, you could have that as a pod on a stand that you literally move around where you need it. Again, this is just showing the example because you had power right at this location. Instead of this mesh access point, you could do something like this, right? And then just have this smaller mesh access point kind of wherever you need it, right? So again, just options that you can do. So let's look at total cost for this setup. We have the Rocket 2AC Prism, $205. We have the 10 dBi omnidirectional antenna. We're going to skip the RF armor since, again, that's optional. You can have that, but since you're only going to be outside for a small amount of time with this setup, it's probably not necessary. If you're going through like harsh Pennsylvania winters, then you would want that RF armor protecting the prism and sort of the cables that connect to the omnidirectional antenna. Then we have the US8 150 watt. We have one UAP ACLR on building A, and then we have our Mesh Pro access point. Building B, we have the NanoStation M2, the LR, and the M Pro. Building C, we have the M2, the LR, and the M Pro. We're looking at a total of $1,569 if you're buying everything brand new. Again, though, I went through eBay, and I just looked at, like, generally, what could you probably get this stuff for on eBay? And instead, you could actually get everything for just over $1,000. Okay, so I see about $1,011. Again, depends on your timing on eBay and whatnot. And I didn't include in this price this extra pod here, right? So this is just the equipment that I have at building A, the equipment that I have at building B, and the equipment that I have at building C. You're looking at just over $100 if you were going to buy all of that stuff used. Excuse me, just over $1,000 if you were going to buy all that stuff used on eBay. So hopefully, you didn't give me a budget, Bob, but hopefully that would be like within your budget, like around $1,000 for this full setup that's going to power the New Germany, what's it called? The New Germany Grove Festival grounds. All right, so there you go. Again, if anyone wants to help Bob out by donating some equipment, get in touch with me at info@crosstalksolutions.com, and I will get you over to Bob. If you guys have anything to add to this setup, do you agree with my setup? Do you think it's a good setup for Bob? Do you think that there's anything that you would change instead of the way that I have it configured? Put that down in the comments below. That is going to be excellent feedback for not only Bob, but for anyone else who's watching this video and might want to attempt a similar setup. Okay, hope you guys enjoyed this video. If you did enjoy this video, make sure you give me a thumbs up. And if you'd like to see more videos like this, please click subscribe. My name's Chris with Crosstalk Solutions, and thank you so much for watching.